This is video number 2 for sections 3.1 and 3.2, Strange Cases and the Graphing Method. What do we mean by strange cases? Well, certainly the normal thing when you use the graphing method is you graph your two lines and they meet at one spot, that intersection point, and that spot is the solution to the system. But occasionally something strange can happen. So let's take a look at this example problem we have in part A. Here's a system of equations, and the first thing we're supposed to do is to graph this system in our calculator. Now remember, in the calculator, the equations have to be set up in the good format, the y equals mx plus b format. It looks to me like this first one is just fine, but the second one I think we're going to have to fix. We just need to get that y by itself. So it looks like I'll start by subtracting x from both sides. That's going to give me negative 2y equals negative x plus 2. And then divide both sides by negative 2. Now that y is by itself. And on the right, I just need to distribute the negative 2 into both parts. There's an understood 1 here in front of that x. Negative 1 over negative 2 makes positive 1/2 x, and then positive 2 divided by negative 2 is negative 1. So now I have the second line also in the good format. Well, let's go to the calculator and take a look. All right, so here's the main screen of the calculator. If I want to solve using the graphing method, I need to go to the y equals button, and I need to make sure my plots are turned off. They are on this calculator. I should also get rid of equations I'm done with by going to them and hitting clear. The first equation was y equals 1/2 x plus 3. And the second equation, y equals 1/2 x minus 1. As far as a window, the numbers look normal. I think I'll just go to the zoom standard window. That's zoom followed by choice 6. And here is a picture of each graph. The handout says, what do you observe about these two lines? And of course, from a visual perspective, we can see that these lines are parallel. The next part on the handout says we really should have known this was going to happen. Take one more look at the equations back in the y equals area. We knew that these lines were going to come out parallel because the slopes are the same, but the y-intercepts are different. That means they're different lines, but they have the same slope. Well, that's what parallel lines are. Let's go back to the graph. The handout goes on to say that when we're solving a system, we're looking for an x and a y that satisfies both equations. In other words, an x and a y that's on both graphs. Is there such a point? Well, the answer is absolutely no. These lines are parallel. That means they never meet. There is no point that is on both of these graphs. So back to the handout, what kind of answer do we give for this problem? Well, if you're using the graphing method and you end up with parallel lines, then you can either say this system is inconsistent, or you can say it has no solution. You need to make one of those conclusions at the end of the problem. All right, let's go down to letter B. Here's another strange thing that can happen to you when you're using the graphing method. Here's another system. Question 1, what would happen if you graphed this system on the TI? Well, once again, the first equation is in the right format, but the second equation is not, so we're going to have to fix that. The second equation is kind of a mess. I think what I would do to start is clear the fractions. The LCD of this equation is 4, so I will just multiply both sides of the equation by 4. And really that means I'm going to need to multiply by 4 3 times, once on the left, and then I'm going to have to distribute this 4 into both pieces on the right. So I'll write the times 4 in front of each term, and then I can do my canceling. Looks like here the 4's cancel, here 2 goes into 4 twice, and here the 4's cancel. And so then my equation becomes y equals, looks like 2x and plus 3 when I put it all together. And now, just by clearing the fractions actually, the y ended up by itself. So now my second equation is also in the good format. Now the question says, what would happen if you graphed this system on the TI? Well, if you take a look at the two equations, they're identical. They're the same equation. I don't think I have to go to the calculator to know what's going to happen. Obviously, what's going to happen is they're going to be the same line. They're going to be what we might call overlapping lines. Obviously, this is going to happen anytime the lines are identical. So this is going to happen if the slopes and the y-intercepts are the same. Okay, so as it goes on to say, remember, the whole point here is we're trying to solve the system. That means we're looking for an x and a y that satisfies both equations. From a graphing perspective, that means we're looking for an x and a y that's on both lines. Now remember, we already know what this picture is going to look like, even though we didn't go to the calculator. We know that we're going to have essentially just two copies of exactly the same line. The first line would be there, the second line would be right on top of it. How many xy points are on both of these lines? Well, the answer is infinite. There's tons of xy points on both lines because the lines are lying right on top of each other. How do we give an answer to these kind of problems? Well, if you are solving a system and using the graphing method and the lines come out overlapping, you can either at the end of the problem say this is a dependent system, or you can say there are infinite solutions. We've now covered the only three things that can happen. The lines will either cross once and there will be one solution, the lines will be parallel and there will be no solution, or the lines will be overlapping and there will be infinite solutions.